So today we are looking at pressure. Pressure. All right. Pressure. Usually, pressure we know it by force exerted over on an area. But when we dig deep in the concept of pressure, um, of course, we are saying pressure is the concentration of a force on a surface. All right. And whenever we are trying to define these things, like I'm trying to explain to you guys have to mature from using formulas. For example, of course, you know that pressure, all right, is equals to force um, over area. But what I would want you guys is to evolve from from the mentality that we had in high school of saying, okay, I have a question, they're asking for pressure. Oh, so let me do force over area, then I'll get there. And you even use a different force, you even use a different area to try and get what you're looking for, but that's not supposed to be the case. When I write an equation to say pressure is equals to force over area, the idea is you have to just get the basic concept of pressure from this equation. From this equation, you just have to have the basic concept. This equation is not what is going to give you solutions to physics problems. No. This equation will give you the basic underlying concept behind the pressure. All right. But you discover that in certain instances, you will never even write force over area. You will write different things, but those things should amount to force over area. This is just the basis, the foundation, the building block. Once you understand that pressure, when we talk about pressure, is equals to force over an area, then you build from there. Is that okay? Are you understanding what I'm saying?
Yes.
So I
Yes,
want
sir.
awesome, awesome. So I will always emphasize that you guys should not be looking for, oh, where's the formula? Where's the formula? Let me plug in the formula. Oh no. I want you guys to understand what is happening. All right. And then you can be able to move on like that. So let me give you an example. As you can see in this diagram, in fact, when we talk about pressure, in this topic, we'll be mostly talking about pressure in a fluid, in a fluid. All right. So this is a hydraulic system. All right. This is a hydraulic system. And what happens is that, have you seen that here we have a small surface area? We have a small surface area, not so? And then when we apply a force down like that, all right, we apply a force over a small surface area. It is likely that if we apply a force over a small surface area and induce pressure in this cylinder here, what will happen is what will come out here, all right, what will come out here is a larger force. A larger force will come out here. Why? Because here there's a large surface area. All right. So what will happen is when I induce a small force, okay, let's call this one small force and let's call this one large force. So the concept of pressure is that when I induce a small force over a small area, area is small. I induce pressure in this cylinder by applying a small force and a small over a small area. What will happen is what will come out here will be a big force. Why is it becoming a big force? Is because the area is what? Big, is large. All right. Why is it so? Why is it so? But what you have to realize is that pressure has to be what? The same. All right. Let me give an example. Do you know that 1 over 2 is equals to 5 over 10? Do you know that this is true?
Yes.
Do we know that this is true?
Yes. Yes.
So if we have force, all right, force small over area small, we can induce force which is large if we provide an area which is large. Have you seen this? Why is this? Why did I say that if we apply a small force over an area which is small, we can induce a big force over an area which is big? Is because this is true. This is a small number over a small number, but can induce a big number over a big number. So meaning if I want to lift something heavy in a hydraulic system, if I want to lift something heavy, what do? I just put it over a large surface area in a fluid. I put it on the surface of a fluid which is having a large surface area, but I connect it to a small surface area of a fluid, and I can easily apply my small force here in this fluid where there's small surface area to lift this big force. All right, even here you can see big force. So this is the underlying principle of pressure. And when you can understand what is happening here, you can now solve complex problems. In many, you will see an example which will sort of talk about what we have just outlined, but I just wanted you guys to just understand and appreciate this concept, especially for some of you who would choose a career in engineering. You discover that this will be very helpful for you if you understand this concept. So let's go on to the next slide. The next slide actually just tells us that you can actually manage to sleep on a bed of nails. All right. I want you guys to understand this concept very well. So what happens is that even you, someone, for example, like Florence, right? You can put nails all over this place and then sleep on it. It won't even prick your back. You won't even feel some pain. Why is it so? It's because you have created large surface area. Each individual nail has a small surface area, not so? Has a small surface area. But when you arrange them, they become many. They make an area which is what? Which is large. So if you arrange them many nails, you can make an area which is large. All right. And when you make that area which is large, even your weight, so when your weight comes upon it, your weight, for example, is big, but if you make an area which is large, the pressure that will be produced will be small. All right. So if you have your weight, but you make the area large in the numerator by putting a lot of nails, the pressure that you make will be small. And if you have small pressure, the nails can't prick your back. Are we following?
Yes.
Yes.
So is there anyone who is willing to put nails all over the place and sleep on it? Is there anyone any volunteer?
Me.
Eh?
No, me, no.
Yeah,
No.
I heard someone saying me.
Now someone getting up on day because the
Florence.
area will be small.
Yeah, the thing is, when you're getting up, you have to be strategic. Even when sleeping there, you have to be strategic. Even when getting up, you have to be strategic. You put your arms outside so that you lift yourself with your hands. You don't just stand up. When you stand up from the buttocks, they can enter your buttocks. You will not be happy. So, but the thing is, you understand that with weight like this, if you provide a large surface area, you can make the pressure to be small. And once you just start grasping some of those concepts, do you know the reason why? If this is a wall, and then I have a nail, do you know the reason why the tip of the nail is small? Anyone who knows the reason why the tip of a nail is small, is sharpened to make sure that at the end of the nail, it has a small area. Anyone who knows the reason why we sharpen the nail?
Me.
The pressure.
Tell us.
Because the area, the tip is small so that it sharpens so that we increase the pressure. To increase
Awesome.
the pressure as you are hitting the nail.
Mm-hmm. Mm-hmm. That is very correct. So if I have a force coming from a hammer, I have a force coming from a hammer, all right, and I make my area, I make it what? Small. What will be the pressure? The pressure will be large. Will be large. So to increase the pressure, which can help us penetrate through the wall, we have to make our area small. But if we make our area large, the pressure will be small. So, knowing that you guys have understood this concept, let us look at an example. All right. All right. Let's look at an example. Someone to read for us this example. Let us have Mubanga to read for us this example here. Here.
Okay. A waterbed is 2.00 meters on a side and 30 centimeters deep. A. Find its weight. B. Find the pressure that the waterbed exerts on the floor. Assume the entire lower surface of the bed makes contact with the floor. Data. Dimensions of the waterbed. Length equal to the width equal to 2 meters. Height equal to 0.3 meters.
Okay. Obviously, when a question comes, this data, they will not write it for you nicely like this, but a question will just come like that. All right. We have a wet waterbed, which is 2 meters on a side. All right. So obviously, the waterbed is what? So since they have only given us one side, a waterbed, we expect it to be sort of something like that. All right. It's like a swimming pool. All right. So we have a swimming pool. Now in this waterbed, which is like a swimming pool, they have given us one length that it is, they've given us one length that it is 2 meters. 2 meters. So them giving us one length of 2 meters, we expect that even here, it is equal to 2 meters. There it's also equal to 2 meters. Even there it's equal to 2 meters. All right. So no wonder we say the length should be equal to width, should be equal to 2 meters. But they sometimes they don't always mention everything in the question, but you can use what we call common sense. Someone said common sense is not common to everyone. Is that true? Common sense. Does everyone have common sense?
No.
Yeah. Oh.
It is true.
Yeah. So, but everyone is expected to have common sense. You will realize that in some questions, not all information will be given, but they will expect that because of your common sense, you can sense that Here, even if they have left out this information, it's supposed to be like that. So I engage you, I urge you to be using common sense when you be solving your questions. So they give you that, how deep is it? 30 centimeter. And they are telling us to find the weight, all right? How can we find the weight, all right, with just this information? Oh, it is 200, I mean, we have 2 meters, 30 centimeter deep. Anyone who can help us? How can we find the weight with this information, with this data?
Sir,
Yes.
before we find the weight, I have a question, sir.
Yes.
Though you said we have to use common sense. Now, what if somebody chooses to use the common sense of saying, since this one, this question we are not taught to say it is a rectangle or something like. What if somebody chooses to use the common sense of the water bed is a circle? This is the formula for a circumference. Can
First of,
he also find the same answer?
not at all, he can't, because he has misused his common sense. You see, first of all, you have to realize that they have used the word waterbed, all right? They have used the word waterbed. And after that, they have even given to say side, all right? Does a circle has any side, a circle like this? Which one is the side? Is it this one or that one? Which one is the side? We are using common sense now. Mr. Wisdom.
Yes, sir.
Which one is the side on the circle?
The lot of it.
So common sense does not allow us to have circle. All right. Common sense can only give us a rectangle or a square. Now, since they just gave us one dimension, we expect it to be a square. If it was a rectangle, they would have said on one side is 2 centimeter, on one side is 2 meter, but on the other side it is maybe 4 meters. But since they've given us one length, we expect it to be square. All right. So we have the length. I mean, we have this is the width. We have the length, and we also have the height. We have the height. What comes to your mind when you have length? When you have length times width times height, what comes to your mind?
You can find volume using the sides.
We have the depth, the side, and we have said the length and the width and the height are these. This height is the same as depth. We have the length, width, and the height. We can find it. We can use it to find volume. But how can us finding volume help us to find the weight? Anyone else? Anyone else? Since we have now the volume. Okay, we have Precious again. You can go ahead.
Yeah, since here we'll be given the size, so you find the volume using the size that we've been given. Then you know that here we're talking about water, so you can use the density for water, and you know the formula for weight is volume times gravity times the density. Then you use that to come up with the weight.
Awesome, awesome. And that is how we are supposed to go about it. All right. You know, even if we said buoyancy force is equals to volume times density times acceleration due to gravity. It is because it's a what? It's a force. All right. It's a force. We can use this same concept Why did we use volume times density times acceleration due to gravity? We used the volume times density gives us the mass, and mass times the acceleration gives us what? Force. All right. All right. So the reason why we're using Buoyant's force is this is because we are saying that this mass times acceleration due to gravity is being overcome by buoyancy. Buoyancy is the one that is overcoming this. So this buoyancy, since it is overcoming the mass and the acceleration, it's overcoming it upward. We're giving it an upward force. We can also use this same concept to find the weight, because if we have the volume, we have acceleration due to gravity and density of who knows the density of water? Density of water is also regarded as common sense. Anyone who knows the density of water?
1000 kg per cubic meters.
Awesome. Awesome. So you should do, sometimes you don't always have to expect them to give you the density of water. They assume that density of water is the common sense. So sometimes when they have not given the density, sometimes they, if they specify to say sea water, sometimes they say sea water. If they say sea water, then sometimes it's usually 1054 or something like that, 1054 kg. If they use the word sea water, sometimes they will give you the value for sea water. But if they just say water like that, then you know that it is 1000 kg per meter cubed. So you should know it from today that density of water is common knowledge, common sense. Is that okay?
Yes, sir.
Awesome.
Yes.
Yes, sir.
So just like what Precious said, we know that weight is equals to mg. Mass, we can also express it as mass times, we can express it as volume times density. And then volume, we know that we have been given, we know the volume is, we can compute it like that. And then weight, we know that this is the density of water, is 1000 kg meter per meter cubed. And this is the volume which you have here. And this is G. We can compute it. We can use it to find the weight. Is that okay?
Yes.
Yes.
Awesome.
Yes.
Awesome. So now we are now going to the next part, which is saying find the pressure that the water exerts on the floor. Assume that the entire lower surface of the bed makes contact with the floor. All right. Even before we look at this expression here, even before we look at the answer here. All right. So we are being told to find pressure. Even we know that pressure is equals to force over area. Now we also know that weight is also a what? Weight is also a force. All right. So now weight, we are saying weight is also a what? A force. Now, what about the area? Which area are we talking about? All right. Which area are we talking about? We are talking about, we are still talking about this square. So if here this is 2 meters, and also that is 2 meters, and you know that the area of a square is just the length squared, since all these sides are the same, we can easily find the area. We can multiply 2 times 2 to find the area. And then to find our pressure, we get this same weight. We divide it by our area. then we get our pressure. This is what we have done here. This is our force, and it is this value which we found here. That same value, divide it by our area, we get our what? Our pressure. Our pressures, we have found our pressures. Are we together?
Yes.
Yes, sir.
Have you seen that finding pressures is very easy with just these parameters which we have here? Not so precious.
Yes, it is.
Okay, so Zoom is saying time is going out. So let's quickly go and come back to this link, and then we finish up on what is remaining, because what is remaining is we now, after just understanding pressure now, we now want to see how pressure changes when we are in a fluid. When we are in a fluid at a certain height, how does the pressure change? So we have gotten the basic concept of pressure, and then now from there we can build up now bigger things. So the idea is that once you get the concept, no matter how hard the question will come, you will solve it because you know the concept. Me, I can even